JavaScript has a large set of statements which look pretty much like the set of statements that you'd find in any of the other C languages. But there are a few differences, and we'll look at those. First off, it has labeled break, which is a really nice thing. It copied this from Java. So I can put a label on a loop, and then I can break from that loop. And so if I have nested loops or nested switches, I can bust out of the middle and get down to the bottom. It's really handy. It has a for statement, which we can use to iterate, for example, through the elements of an array. So if I have an array called array, I can go through its length and visit all of its members. And in the body of the loop, array sub I will be the current element being considered. There's also a special version of the for statement, which is for objects, which allows us to iterate through all of the keys that are in an object. The syntax is a little bit different. We say name in object, and for each iteration through the loop, name will be set to one of the keys from that object. Unfortunately, we'll also go through all of the keys of all of the objects that this object inherits from, which is usually not something that you want. So to avoid against that, you have to write as the first statement of the for, if the object has that property, then we'll do what we want to. Otherwise, we probably want to reject it because it's something we're dredging through the inheritance chain. This is an annoyance. And a lot of people who ignore this pattern end up having programs that get broken when they work with other people's programs. So this is a disgusting thing you have to do, but I highly recommend that you do it in all of your for statements. JavaScript has a switch statement just like the C languages, which provides a multi-way branch. But it has some advantages. First off, the switch value does not need to be a number. It could be a string or anything else. That's really, really handy. And the case values do not have to be constants. They can be expressions, which could also be handy. So for example, I could have a switch statement in which I'm comparing against strings. And if I match one of those and I do that, it still has the same broken switch statement as everything else in that you have to explicitly terminate each of the clauses. That's unfortunate, but that seems to be the standard. And then it also has a default, so you can catch all the else cases. JavaScript has a throw statement, so you can throw an exception from your code. You can generate an exception object by calling the new constructor. Or you can use an object literal and make one in place if you don't want to go to that trouble. And we'll talk more about object literals as we go on. Once you throw, you might expect that the exception will be caught. So JavaScript has a try statement. You can try some bit of code. And if an exception is thrown in it, it will be caught in the catch clause. Because we don't have classes in this language, there will only be one catch clause. You won't have one per exception class. And your catch clause will then have to determine what sort of exception it is and decide if it wants to handle it or throw it on or whatever. Any questions about that? OK. And there's a try statement, there are exceptions which are built into the JavaScript system itself. So the JavaScript engine knows how to throw all of these exceptions. And all of these exception constructors are available to you as well. So you can throw any of these, or you can make up your own exceptions. JavaScript has a with statement, which was intended as a convenience for dealing with objects. But there is an error in the way it was conceived, and so I don't recommend you use it. It's ambiguous and error-prone. So here's an example. We have a with statement with some object, foo equals null. Now, it could mean o.foo equals null, or it could mean the global variable foo means null. Anybody have a guess as to which one it means? Well, it turns out you can't tell. It could do either of them, depending on what O is. So programming is hard enough If you're using constructs in which you can't predict when you read the program what the program's going to do, best not to use it. So I recommend stay away from the with statement. JavaScript has a function statement, which is used for declaring functions. A function has a name, an optional set of parameters, and then a set of statements which get executed when the function is invoked. There's a var statement which defines variables within a function. You don't specify types in this language, so you don't say int a or something like that. You just declare that it's a variable. Optionally, you can initialize the variable with values. So I can say var number of errors initialized to 0, or I can just give a list of variables separated by commas. Now, if you don't give an initialization value, it will be set to undefined for you. In JavaScript, blocks do not have scope. This is a departure from all of the other C languages. I think maybe it was a bit of laziness when they were writing the compiler. This causes people to think incorrectly about variable scope. There is only function scope in JavaScript. So if you declare a variable any place inside of a function, it's visible everywhere in the function. And if you declare a variable twice in a function, it only gets created once. There's no error for that. Yeah, so this was a mistake, and the mistake persists in the language. So, yeah?
It also implies that you don't have to specify my variables in a single place.
Right.
Does it also mean I have to declare my variables?
That's another good question.
You just use the name and have it appear.
JavaScript has implied globals. So if you, yeah. So we'll talk about these more later.
Yeah.
But if you create a variable and forget to declare it, JavaScript assumes that you meant it to be a global variable. So for example, if you forget to define I, you've created a global variable called I. And if you make that same mistake in 2 places, there's a good chance your program is going to fail. JavaScript has a return statement, actually 2 forms of them, one in which it returns an expression and the other where it appears to return nothing. Except in JavaScript, every function will return a result. There is no void type in JavaScript. So if you have a function which does not return something explicitly or falls through the bottom, that function will return the undefined value, except in the case of constructors, in which you'll return the new object. And we'll talk about those in a little bit. So we said everything else in the language is objects. And objects can contain data and methods, and objects can inherit from other objects. So objects in this language are collections. An object is an unordered collection of name-value pairs where the names are strings and the values are any type, including other objects. It's very good for representing records and trees. You can think of every object as being a little database. We also have an object literal notation in this language, which is extremely convenient. It provides a way of conveniently creating a new object. Again, the names can be strings, but names can also be simply names. So in some cases, the quote marks around keys are optional. The values can be any expression. Colons separate the names and values. Commas separate the pairs. Object literals can be used anywhere that a value appears. So here's an example of an object literal. I declare a variable called myObject, which contains this object, which has a name and a goto and a grade and a level. So you can think of it as creating this little table in memory in JavaScript, where these are the keys and those are the values. And then I can access that material in the language. I can say myObject.name, and that will set the name to Jack B. Nimble. I can also use the subscript notation. I can say myObject sub the name or the string goto, and it will do the same thing, put jail into the destination. So these 2 notations are interchangeable in most cases, except they're not in this case, because goto is a reserved word. And one of the errors in JavaScript is that I cannot have a reserved word in this position. But I can have a string in that position. So that's why you need to be aware of the reserved word policy. Another way that I could make an object is to have a maker function. So I'll pass a bunch of material to the maker function and have it make an object for me and then return it. So in this case, I've got a maker function which will create an it variable, and then it will fill that object up. Or here, the empty curly braces mean make a new empty object. So I then assign to that object a name, a goto, a grade, a level, and then I return it. Okay, so the other way I could have made my object would be to call a maker function and then pass the material that I want it to construct with. Now this maker function could get arbitrarily complex. Instead of just taking the values it's passed and doing stuff with it, it could go do computation or call other functions or look at other variables or whatever in order to decide how to build the thing. But this is sort of the simplest kind of function that makes an object. So here's we've taken that same object and we've made the object a little bit more complicated because we've added a format field to it now. And its type is an object. So this shows an example of how we can have nested objects in this notation. But all scrunched up like that, it could be really hard to read. So this can be a lot easier to understand if you take advantage of pretty printing. Let's see. In this case, it's very clear what the structure of this object is going to be.
What was the question?
The question was, could I have a trailing comma here? And the answer is sometimes, so no, really. We'll look at an example later of how that becomes a problem. So we can use an object literal any place we can expect a value. So any place in the language where we could have any kind of expression or variable, we can stick one of these in there too. So I can pass an object to my function, and my function doesn't know if this was a predefined thing or something I defined on the spot. It just gets an object with all those values in it, and that can be pretty handy. Or here again, I'm going to throw an exception. An exception object should have a name type and a message. I can just make it dynamically. I don't need to create a constructor or call constructor to throw an exception. I'll confess I once wrote a really horrible API in JavaScript. I had, it was some years ago, I had a super div constructor which took like 10 or 20 parameters. And it was really hard to remember what the names of all the parameters were. And it turned out most of the time you didn't need all of them. And then later we figured out that some of them really shouldn't have been parameters at all. They should have been in style and so shouldn't have been in this list. But by then the API was stuck and we couldn't take them out without breaking it. Had I been smart, what I would have done instead was pass an object to this thing. And that object would allow me to have what would practically be named parameters. It wouldn't matter what order they're in. It could detect when things are missing and provide suitable defaults. It would have been a much cleaner API. So generally, if you find yourself doing something with more than a couple parameters in it, step back and think about refactoring it as something that takes a single object. One of the nice things about objects in this language is that they can be augmented. By that I mean you can take an existing object and add new stuff to it at any time. Give it new members, new methods. And we do that simply by assignment. So if I want to make an object that is bigger, I don't need to make a new class. In fact, there are no classes. I just do it. So if I decided that I wanted to add a color model member to the format of this thing, I just assign it, and boom, it's got it. So the general pattern is I have an object, a key for that object, and a value that I'm assigning. And this works anytime for any object. When objects are created, they're created with a secret link to another object. This is the method by which inheritance is achieved, because objects are able to inherit from other objects. If we attempt to access a member from an object and that access fails, the system will silently go to the object that that object was linked to and see if it has a member with that name. And if it does, it returns it, and computation goes on. If it doesn't, then it will finally return undefined. The secret link is not used in storing. So if I store something to an object, it goes to that object. We never go down that chain. We can use the object function to make a new empty object which has that linkage to object O. So this is the basic fundamental operator in prototypal inheritance. We'll talk a lot about how this works. So let me put in a picture for you. Maybe it'll make it clearer. So I'm going to make my new object, and I'm going to have it inherit from my old object by making it with the object function. So what it creates in memory is a new object, which is an empty object, which contains the secret pointer to my old object. Then I can go ahead and start augmenting this one. So I can assign it a name that creates a name in this object. No change to this one because I'm doing the assignment to this one. Okay, then I'm going to increment its level. Now this one initially didn't have a level. So it went to this one. It's got a level, 3 plus equal, add 1 to it, store it here. That creates a 4 here. And then again, I can augment it by adding another thing here. But the other, let's see, if I ask this, my new object what its grade is, there's no grade here, so it'll return A. It inherits that value from this object. So linkage provides a simple inheritance mechanism. Any object can inherit from an older object. Some languages have classes, methods, constructors, modules. JavaScript has functions. And JavaScript's functions do the work of all of those things. Instead of classical inheritance, we have prototypal inheritance. It accomplishes the same things, but it does it differently. It has, I think, greater expressive power, but it's different. If you don't understand that it's different, it's going to be really frustrating. So instead of organizing objects into rigid classes, new objects can be made that are similar to existing objects and then customized. Object customization is a lot less work than making a class, and it's a lot less overhead. One of the keys to doing that is the object function. The other key is functions in general, and we'll talk about how those work. Yeah?
What happens to the new object if the old object is set to undefined, for example?
That's a good question. What happens to the new object if the old object is set to undefined? Let me go back a little bit. OK, so suppose we say my old object equals undefined to make it go away. Well, this object still exists. So my old object was a reference to this value. This value still exists. So this linkage is not broken. But the other thing that could happen is I could change this guy's grade to B. The value this guy inherits is now B. So he can be sensitive to the dynamic state of this object. Or I could delete the grade member from this. Now he no longer has a grade. Yes? That's a good question. So what happens to this 4? Once the level is stored into this object, we no longer look at this one. So this one's level is now self-determined. One thing which is a little odd, though, is if this guy ever deletes his level, he'll now have this level, because this one will now shine through again. So sometimes deleting things doesn't cause them to disappear. It causes them to appear to mutate. Yes? It's only single inheritance. So you only get one of these arrows per object. But as we'll see, you can have long linkages of these objects. Yes? is there any way to change the linkage after the fact? There is in Mozilla. They have a non-standard thing, and we'll look at that briefly in the advanced JavaScript class. I don't recommend it because it's not standard and it won't work anywhere else. And I think it's probably a bad idea anyway. Yeah?
Does JavaScript cope with circular linkage?
Does JavaScript cope with circular linkage? You can't, because an object can only be made from an existing object, and those linkages cannot be changed. So there is garbage collection in this language. You'll be glad to know that, and it's mark and sweep. So cycles do get reclaimed. OK, so you can have this link going to another object in which you inherit properties. The end of that link chain is always directly or indirectly object.prototype. It's always the last in the chain. So object.prototype is a place in the system where the system provides built-in methods for you. It turns out that they're not very useful, unfortunately. There is one that we saw earlier, has own property, which is a little bit useful. Surprisingly, there is no copy method for objects in JavaScript. It seems like an omission just doesn't have it. Also, it doesn't have an equals method in it, which also seems like an omission. You can use the equality operator, which tells you if two references are the same object, but it doesn't tell you if two objects contain the same stuff. JavaScript just doesn't have that. It seems odd, but they don't. So there are three ways in which we can make a new empty object, which we can then stuff full of good stuff. We can use the new object constructor, or we can use an empty object literal, or we can call the object function passing it object.prototype. All three of these will do exactly the same thing, return exactly the same result. I recommend the empty object literal because it's the smallest, and once you learn to read it this way, it's also the most expressive. Objects are passed as, or objects can be passed as arguments to functions. They can be returned by functions. Objects are always passed by reference. They are not passed by value. The double equal or triple equal operator compares object references but not values. So it will return true only if both operands are the same object. Doesn't help if they're similar objects. There is a delete statement which can be used to delete elements from an object. You say delete the object and then sub the name or dot the name. And that removes it. Actually changes its value to undefined, which does the same thing. Objects or arrays in JavaScript are unusual. They're not like in most other languages, because array inherits from object. The way arrays work is that array indexes are converted into strings and then used as names for retrieving values. They're not the position indexes into a list or a string of memory. It's really efficient for sparse arrays and not very efficient for almost all other applications, including the ones that we write. It does have one advantage, though. There's no need to declare the length of an array when you're creating it, because it doesn't matter. And you also don't have to give the type of the stuff going into the array, because that doesn't matter either. Yes? What's the threshold of sparse? Pretty sparse. You know, if you've got like 1% population in your array, then this is a really effective way to do it. For anything in which memory tends to be pretty linear, this is not an efficient implementation. Arrays have a length member, which tells you, which looks like it should be the number of elements in the array, but it's not. It is one larger than the highest integer subscript, which, depending on the composition of the array, may or may not be the same as its actual length. So what that does is allow you to use a traditional for loop to go through all of the members of the array. So the length operator does that, or the length operand or member does that. There are array literals in this language, which work similarly to the object literals. An array literal is in square brackets with values separated by commas. So here I can make my list, which contains these 3 vegetables. And then I can append to an array. Since arrays don't actually have a length, they don't actually have an allocation, we can add new stuff to any array at any time. So if I assign to my list at my list.length, this will be 3. So we assign the 3rd subscript, give it barley. That changes the length of the array to 4, because the length is always 1 bigger than the last index that we assign to it, or the last biggest that we assign to it. We can't use the dot notation with arrays because there's a confusion with dots and numbers, but we can use the subscript notation. And empty brackets is the preferred way to create a new array. Recommend you don't say new array to create a new array. Yes?
Basically, it creates the same object when the hash names are 0, 1, 2, right?
That's a good question. Does this create something similar to having an object literal in which the keys are quote 0, quote 1, and so on? Very, very similar. The difference is that it also has array nature, which means that the length member means something, and it also inherits the array methods, and we'll look at those. Otherwise, it's the same stuff. So arrays have methods. These are some of them. We can concatenate arrays together. We can join an array, which means we turn all of its members into strings and concatenate them all together. We can push and pop things on the end, so we can treat it like a stack. We can slice it, sort it, splice it. We can do surgery to it. We can delete members from an array by deleting them the same as we can with objects, but it doesn't do what you think it does. It removes the element from the array, but it leaves a hole. It doesn't change the subscripts of the other members. If we want to get rid of the hole, we need to use the splice method. So let me show you an example of that. I've got an array containing A, B, C, and D. I delete subscript 1. Because arrays start from 0, we end up with this structure. The indexes of these 2 didn't change. If we want to close up the hole, then we could use splice, which says starting from the first index, delete one thing and insert nothing in its place. So that will then give us this result. So since objects and arrays are so similar in this language, I mean, they're almost the same thing. When to use one and when to use the other. In fact, if you use the wrong one, your program will probably work most of the time, so you don't get good feedback when you're making a mistake. So this is how you decide. Use objects when the names are arbitrary strings, and use arrays when the names are sequential integers. Don't be confused by the term associative array and think that means you use an array. In this language, arrays and objects are both associative arrays, but the thing that you think that an associative array is the object. Yeah, right. Okay, so we talked about how objects have these secret links by which they inherit things. Arrays also have secret links, and they get linked to array.prototype. You don't get to choose with arrays, and we'll talk about the implications of that later. So if you get a value, how do you determine if it's an array or if it's an object? As we'll see later, there's a type of operator in JavaScript, but it doesn't help us to do this distinguishing. So there are two methods that do work. One is we can say value.constructor, does it equal array? The other is we can say array instance or value instance of array, and if that returns true, then we can think it's an array. Although neither of these work if the value came from another frame. We'll talk later about why that is. This is an omission in the language, which I'm hoping gets fixed someday. Okay, so we can't really use, we cannot inherit from an array effectively. So you can't use arrays as prototypes. The reason is that the thing that gets produced by the object operator is going to be an object. It's not going to have array nature. The length member isn't going to work. It won't be right. But what you can do is you can augment an individual array by assigning methods to it. Since it is underneath an object, it's able to receive any kind of value, including functions, and any kind of key, not just numbers. The other way you can augment an array is to augment all of the arrays in the system at once. And you can do that by assigning methods to array.prototype. We'll look later about how that works.